notation. Okay, we will revise that part. Okay, I will write one equation. One is less than log n is less than root n is less than n is less than n log n is less than n square is less than n cube is less than 2 raised to n is less than 3 raised to n is less than n raised to n. Okay, suppose n is equal to 1. We'll take first condition. 1 is less than log n. So n is equal to 1. 1 is less than log 1. This is not possible. This is not possible because log 1, value of log 1 is 0.000. This is not possible. This is or these all statements are not possible for small values. These are possible for larger than 10. Okay, we'll take one example. Suppose n is equal to 10. So 1 is less than log n, that is 1 is less than log 10. So what is the value of log 10? 1.00. Okay, suppose n is equal to 11, then log 11. It is possible. Are you getting? Hello? Hello? May I audible?
Yes, sir. Yes.
Okay. Are you getting? Are you getting or not?
Yes.
Okay. So suppose if we take n is equal to suppose 10, we'll check for all. Suppose here 1 log 10 or log 11, then root of 11, then 11, then 11 into log 11, then 11 square, then 11 raised to 11. Okay, see here 1 is less than 1 point, what is a something value, 2 3 whatever, then less than, what is the value of root 11, 3 point something is less than 11, then here 11 into 1.23 whatever the value, then square of 11 square, that is 121, then 11 raised to 11. Okay, so This is the general equation for asymptotic notation. This is the general equation for asymptotic notation. If you are taking a values less than 11, then this equation cannot satisfy for all points. Okay. If you are taking values greater than 11, then it satisfies, this equation satisfies for all parts of this or all points of this equation. Are you getting? Okay, समझता है?
Yes, sir.
Okay, we have seen that is the equation 1 is less than log n, then less than root n is less than n is less than n log n is less than n square is less than n cube is less than 2 raised to n is less than 3 raised to n is less than n raised to n. Okay, so in previous lecture we have seen that 3 types of asymptotic notations. We will see one by one. First is big OH notation. Big OH notation symbol is capital O or big O. Symbol is capital O and this is upper bound. Why this is upper bound? We are going to study. So first we will see the definition of this. So the function f of n, the function f of n is equal to order or big O of g of n. The function f of n is equal to big O of g of n if and only if and only if there exists a constant c. There exists a constant c or positive constant c and another constant n0 which is greater than 1 or greater than equal to 1. Okay, such that so such that f of n is less than equal to c into g of n for all the values of n is greater than equal to n0 for all the values of n is greater than equal to n0. This is the definition for big OH. Notation, then symbol is capital O. The function, there are two types of functions, f of n and g of n, such that f of n is equal to big O of g of n if and if only if there exist two constant such that c is positive constant and n0 is greater than equal to 1, and the function f of n and g of n such that f of n is less than equal to c into g of n for all values of n which are greater than equal to n0. We'll see one example. Suppose f of n is equal to 2n plus 3, f of n is equal to 2n plus 3, then suppose we are writing this equation, then 2n plus 3 is equal to what? We should have to find the values such that here the value is c into g of n. We should have to find which value comes here, what is the constant and what is the n, what is the function. Suppose here the equation is f of n. Here suppose here f of n is equal to 2n plus 3. Okay, and we are going to write this function in this format. So f of n is equal to 2n plus 3. So 2n plus 3 is less than equal to c into g of n, and here we are finding the values of c is equal to what and g of n is equal to what. Are you getting? Hello, hello, समजतंय?
Yes,
समजत नसेल तर विचारा, हा थोडा मॅथमॅटिकल कन्सेप्ट आहे. हॅलो, हॅलो, आवाज ऐकू येतोय तुमच्यापर्यंत?
yes, sir.
ओके, तुम्हाला डेफिनेशन समजले याची? Big OH, a function f of n is equal to big O of g of n, हे कधी अस्तित्वात असणार आहे? इफ अँड ओनली इफ जर काय असणार आहे, देअर एक्झिस्ट c is positive integer and n0, c is any positive constant and n0 is positive greater than one constant, or positive constant but greater than 1. Okay, and we can write this equation, that is f of n is equal to order of or big O of g of n in this format, when f of n is less than equal to c into g of n for all values of n is greater than equal to n0. ही डेफिनेशन समजले तुम्हाला? हॅलो, हॅलो.
Yes.
Okay, we'll take one example, then you will understand. See here, suppose here f of n is equal to 2n plus 3. Okay, and we want to write in f of n is less than equal to c into g of n in this format. So f of n, that is 2n plus 3, is less than equal to c into g of n. Here we should have to find the values of c and g of n. C is any constant, any positive constant. Okay, and n, g of n, that is here n is this variable, we'll take as it is. Okay, and c is any positive constant. Suppose I have taken 10n. Here I will write 2n plus 3 in less than equal to 10n. Here suppose this is a constant c, constant, and this is g of n. This satisfies the equation. Put if n is equal to 1. If n is equal to 1, then satisfies equation will satisfied or not? Equation satisfied होईल का? If we put n is equal to 1. Hello. हॅलो, तुम्ही जर उत्तर दिली नाहीत, तुम्हाला नाही समजू दे चालेल, पण तुम्ही जर उत्तर दिलं नाही तर मला कसं समजणार की तुम्हाला समजतंय किंवा नाही? हॅलो, हाऊ कॅन आय अंडरस्टँड? हॅलो, आवाज ऐकू येतो तुमच्यापर्यंत?
येस सर.
ओके, तुम्हाला हे समजलंय किंवा समजलं नाही काहीतरी सांगा. समजलं नसेल तर नाही म्हणून सांगा, चालेल.
रिपीट.
हा, मग असं काहीतरी कळू द्या ना. वन मिनिट. ओके, आपल्याला बिग ओ एच नोटेशन बघायचंय. बिग ओ एच नोटेशन मध्ये दोन गोष्टी आहेत, दोन फंक्शन आहेत. एफ ऑफ n and g of n, दोन वेगवेगळी फंक्शन आहेत. ओके, ह्यांच्यामध्ये रिलेशन काय आहे? एफ ऑफ n इज इक्वल टू बिग ओ ऑफ जी ऑफ n. हे कधी असणार आहे रिलेशन? इफ देअर इफ अँड इफ ओनली देअर एक्झिस्ट positive constant c. If there exists positive constant c and n0 which is greater than equal to positive 1. इथपर्यंत समजलंय?
Yes, sir.
ओके, आता ह्या इक्वेशन मध्ये हे जे इक्वेशन मांडलंय आपण, या इक्वेशन मध्ये काय सांगितलंय की पॉझिटिव्ह दोन कॉन्स्टंट पाहिजेत. ओके, आता इथं दाखवताना कसं दाखवणार? तर एफ ऑफ एन इज लेस दॅन इक्वल टू c into g of n. Okay, where c is positive constant and n is always greater than equal to n0. Okay, इथपर्यंत समजलंय?
येस सर.
ओके, आता मला याच्यातलं समजा तुम्हाला एक इक्वेशन दिलं, f of n is equal to 2n plus 3 दिलंय. f of n is equal to 2n plus 3 दिलंय आणि तुम्हाला फाइंड आउट करायचं आहे की c and g of n फाइंड आउट करायचं आहे. म्हणजेच मला ह्या इक्वेशनचा वापर करावा लागेल. ओके, म्हणजेच मला हे इक्वेशन कसं मांडता येईल? किमती सबस्टिट्यूट करूया त्या इक्वेशन मध्ये. काय असणार आहे? एफ ऑफ एन इज लेस दॅन इक्वल टू सी इंटू जी ऑफ एन. ओके, सो एफ ऑफ एन काय आहे? 2n plus 3 is less than equal to. आता c काय आहे? तर c is any positive constant. ओके, n काय आहे? Any positive constant. Okay, so suppose in this case, suppose I have taken 10 into g of n n. Suppose I have taken 10n. आता हे इक्वेशन सॅटिस्फाय होते का? If n is equal to 1. सॅटिस्फाय होते का बघा? एनी कॉन्स्टंट सांगितलंय, यू कॅन टेक एनी कॉन्स्टंट. ओके, हे इक्वेशन सॅटिस्फाय होते का बघा? इफ n is equal to 1. हॅलो,
येस सर.
सॅटिस्फाय होत आहे? समजा someone has taken instead of 10 7n, then check equation will satisfy if n is equal to 1.
येस सर.
Okay, suppose someone has taken less than equal to 5n, then equation will satisfy or not?
येस सर.
Okay, now I will write here 2n one minute. 2n plus 3 is less than equal to 4n.
नो सर.
No. Up to 5, you have say yes. For this case, yes. For this case, yes. For this case, say no. Why? What is the reason?
Because it is not less than equal to.
Okay, this is first point. What is second? Suppose instead of I will erase this definition. Suppose instead of 10n or 7n or 5n, someone has taken 2n plus 3 is less than suppose n square or 5n square or instead of n square 1 minute. Okay, 5n square. If n is equal to 1, satisfies the equation.
Yes.
Yes,
Okay,
sir.
this will satisfy the equation. Suppose someone has taken 2n plus 3 is less than 5 into, suppose n is equal to 2. Okay, 2 raised to 2 here, in this case here n, and n is equal to 2, satisfies the equation.
Yes, sir.
Okay, see, for this case, see, first case is we have taken 10n, second case we have taken 7n. Forget about the constant, forget about the constant. So here constant, what is the definition? C is greater than 0 or any positive constant which satisfies the equation. So here, what is g of n? G of n is n, and see the above longer equation, that is 1 is less than log n is less than root n, whatever. So in this case, n, this part satisfies. Okay, and from this point to, for this example we are taking a this point towards right side, this is upper bound, and from this point to this side, this is lower bound. Okay, and what is n? N is average bound. See, for 10n, 7n, 5n, this is average bound. If we are going towards a right side, it will satisfy the equation. If we are going towards a left side, it it is not satisfying the equation. Are you getting? समझ
Yes, sir.
Okay, what is upper bound, what is lower bound, हे दोन concept समजले तुम्हाला? Okay, I will take another example. Suppose f of n is equal to 2n square plus 3, and we should have to find c and g of n. Then we'll write the equation f of n is less than equal to C into G of n. Okay, so 2n square plus 3, okay, into less than equal to C into G of n. Okay, in previous example, we have taken f of n is equal to 2n plus 3. Keep in mind here n. So see in this equation, n is average, and addition of these two digits, that is we have taken 2n plus 3 is less than equal to 5n. Are you getting? In last example, we have taken like this, n as it is 2n plus 3, 2 plus 3, that is 5. Similarly, here we can write, hello, 2n square plus 3 is less than equal to 5n square. Hello,
Yes, sir.
hello, आर यू गेटिंग? पहिल्या एक्झाम्पल मध्ये कसं घेतलं आपण, n ला n ठेवलं आणि 2 प्लस 3 घेतलं. सिमिलरली इकडे घेऊ शकतोय, n स्क्वेअर ला n स्क्वेअर ठेवू शकतोय, 2 प्लस 3 5 घेऊ शकतोय. दिस सॅटिस्फाइज द इक्वेशन. Check if n is equal to 1.
Yes, sir. Satisfied.
Suppose someone has taken, because c and c is any positive constant. Suppose someone has taken 2n, 2n square plus 3 less than equal to 4n square. This satisfies equation if n is equal to 1. No,
No, sir.
this is not satisfied. So there is a technique to find C, addition of these, okay, addition of these, okay, into take a largest power of that variable. Here variable is n, largest power is square. Okay, suppose I will take another example. Now in this case, n square, before going to next example, here see in this longest formula, here n square acts as average, n square acts as average, and from n square towards right side it acts as upper bound, and towards from n square towards left side it acts as lower bound. Are you getting? समजलंय?
Yes, sir.
Yes,
Okay.
sir.
I will take next example. Okay, see here, suppose f of n is equal to 10n square plus 10n plus 3. 10n square plus 10n plus 3, and here we should have to find the values of C and G of N. Then 10n square plus 10n plus 3 is less than equal to what? So here largest power of variable is n square. So 10n square plus 10n plus 3 is less than equal to okay n square. And here which constant will take 11n square? Is it possible? Put if n is equal to 1. This is not possible for 1. Then for 2, okay, for 3, okay, for 4, hello, n is greater than question mark greater than equal to, we should have to check. Suppose someone has written 11n square, then for 4, 16. I think n is greater than equal to 6. Check for 6. Hello, hello, for 6, check the value. If n is equal to 6, put in this example, this satisfies or not? Hello, have you checked for
No,
6?
sir.
No, this is not possible. Then for 7, check for 7.
No, sir.
Wait a minute. Okay, check for 8. Check for 9. Okay. We'll change the constant. Suppose here we have taken 12. Then check, instead of 11 here, suppose we have taken 12. Then put the values. Suppose n is equal to 10. Check n is equal to 10.
Yes, sir. It satisfies.
Hello. Suppose here constant we have taken 12 and n is less than n is greater than equal to 10. Then check satisfies this equation or not.
Yes, sir.
Satisfies the equation for 10. Okay.
Yes.
So in this example, this is f of n is so whatever the power of this variable or index, maximum index of this variable is same here for lowest. If you have taken, suppose instead of n square, here 12 n square you have taken, instead of n square, suppose you have taken n cube, it is also true. Suppose you have taken n raised to 4, it is also true. Okay, but we are taking a smallest which is applicable. So in this example, n square here, n square acts as a average value or average bond. Okay, suppose if we draw the graph of these functions, suppose we draw the graph here, x-axis, here y-axis, this is y-axis, this is x-axis, and here the function f of n goes like this. This is f of n. Here on x-axis, here number of turn or values of n, and here time complexity, here y-axis, and g of n sometimes at lower, but it goes towards the upper side. G of n, whenever you get n0 or n, from that point it g of n goes towards the upper side and f of n goes towards lower side. See in this example, f of n is equal to 10n square plus 10n plus 3, and here c is equal to 12, and g of n is equal to n raised to 2 or n raised to 3 or n raised to 4 and so on. So it goes towards upper side or upper bound. Are you getting? समझ ले? Hello.
Yes, sir.
असिम्प्टोटिक नोटेशन मतलब पहिला पार्ट बिग OH हा पार्ट समजलाय का?
Yes, sir.
Okay. Next, second part is big omega. Okay. I will write a same equation here. 1 is less than log n is less than root n is less than n log n is less than n square is less than n cube is less than 2 raised to n is less than 3 raised to n is less than n raised to n. This is the general equation. Now we are going to see the concept big omega. Symbol is okay. Symbol is like this. That is, in general, it is known as ohm symbol. Okay, but in this algorithm concept, this symbol is used for big omega. So we'll see first definition of this. There are two types of functions, f of n and g of n, and the relation between the function f of n is equal to omega of g of n. F of n is equal to omega of g of n if and only if and only if there exists two constants c and n0, where c is a positive constant and n0 is always greater than equal to 1, such that f of n is greater than equal to omega of g of n. Omega of g of n for all values of n is greater than equal to n0 or 1. Okay, definition same as big OH. Instead of this symbol here, for big OH, we instead of this equation we are using f of n is greater than equal to o, o of g of n. This is for big O or big OH, and instead of this omega symbol here we are using big OH. Okay, definition is same, only there is a difference of these symbols. So we are going to see the examples of this. Are you getting definition समझ लिए? Hello,
Sir.
hello, hello, hello.
Yes, sir.
Definition समझ लिए? Okay,
Yes.
we are going to see the example of this. Suppose here f of n is equal to 2n plus 3, and we should have 1 minute here. Instead of omega, c into g of n. Here there is a correction in this definition, c into g of n. F of n is equal to omega of g of n if and only if there exist two positive constants c and n0 such that c is greater than 0 and n0 is greater than 1, and f of n always greater than equal to c into g of n for all values of n where n is greater than equal to 1. Okay, so we are going to see the example. F of n is equal to 2n plus 3. So f of n is greater than equal to c into g of n, then 2n plus 3 is greater than equal to c into g of n, where c is any positive constant. Suppose someone has written like this: 2n plus 3 is equal to 1 into n, 1n. Here 1 for c and n for g of n. Here c and this is g of n. If n is equal to 1, then satisfying this equation. Hello? If n is equal to 1, then satisfying this equation or not? Hello? मैं audible? आवाज येतोय?
Yes, sir.
Okay. Suppose someone has written like this: 2n plus 3 is greater than equal to 1 into n. That is simple n is written here. 1 is c, and 1 for c and n for g of n. And then if I put n is equal to 1, then satisfies the equation or not? It satisfies the equation. Okay. Here in general equation, here one term was missing. Okay, satisfy or not? Yes, it will satisfy. So here n acts as average. N acts as average, and from this point towards right, it acts as upper bound. And from this point towards left, it acts as lower bound. If we put any value of lower bound, this will satisfy the equation. If we put any value for this c into g of n, this satisfies the equation. And if we put any value from upper bound, it sometimes is satisfies, but always cannot satisfy the value. Are you getting? समझता है?
Yes, sir.
Okay. So suppose we want to draw a graph regarding this, then how it will be look like? We'll see. suppose someone want to draw a graph, then this is y-axis, this is x-axis, here n, here time t, then function f of n goes to this side, whereas the function g of n goes here, here f of n, g of n, and this is the here n0 point where satisfies the equation. Are you getting? समझ Hello.
Yes, sir.
Then we'll move towards next term, that is big theta. Okay, before going to study, I will write the general equation. One is less than log n, is less than n, root n is less than n, is less than n log n, is less than n square, is less than n cube, is less than 2 raised to n, is less than 3 raised to n, is less than n raised to n. So we are going to see the concept is big theta. Symbol is theta. So as as we have seen, as we have seen the big OH symbol is O, it is upper bound, that is suppose this is n is suppose average value of this any function which is given, then if we put any of these values in that function, that is here f of n is less than equal to
पण late होते.
c into g of n, okay, c into g of n. If n is the average value or satisfying the value of this, if we put the right side from the n, that is uppermost values, this will satisfies. In big omega, we have seen that big omega is lower bound, big omega is lower bound, and function we have seen that f of n is always greater than equal to c into g of n. If we put any value of lower bound, if we put any value of lower bound, it will satisfies. Now we are going to see the concept big theta. So there are two functions f of n and g of n. If we write f of n is equal to theta of g of n, if and only if there exist two constants, there exist two constant, c positive constant and n0 is always greater than equal to 1, then we can write or such that c1 into g of n is always less than equal to f of n, always less than equal to c2 into g of n. For all the values of n, and n is always greater than equal to 1 or n0. This is the definition of theta. See the definition carefully. Wait for 2 minutes. Hello, hello. Definition समझ ले. See, there are three definitions in front of you. First, big OH, then big omega and theta. See what is the difference between these three definitions. This is definition for big OH, this is definition for big omega, and this is the definition for big theta. And this big theta is also known as average bond. हॅलो, आवाज ऐकू येतोय माझा?
Yes, sir.
Yes, sir.
Okay, have you seen these three definitions and see what is the difference between these three definitions? First, that is in big OH, there is upper bound, that is f of n is always less than equal to c into g of n. In big omega, that is it is lower bound. In this case, f of n is always greater than equal to c into g of n. But theta, that is average bond, there are two conditions. In big OH and big omega, there is only one condition. See here, only one condition, less than equal to or greater than equal to whatever. But in theta, there are two conditions, that is C1 into g of n is always less than f of n, and f of n is always less than C2 into g of n. That is, suppose this equation can be write like this. Here we have written equation, that is C1 into g of n is less than equal to f of n is less than equal to C2 into g of n. Okay, we will partition this, we will do partition of this equation into two different parts. First part from this to this, and second part from this to this. Okay, we'll see here f of n is less than equal to C2 into g of n, where instead of C2, suppose here we have written like this, c into g of n, where C2 or c is any positive constant. This is the first. Second, instead of C1, in this we have written like this, that is a c into g of n, c into g of n is less than equal to f of n. That is, we can write f of n is always greater than c into g of n. Are you getting? हा पार्ट समजलाय?
Yes, sir.
Okay, see, in first part, see, 1 minute. Okay, see, first part, that is, see this equation f of n. I will write f of n here. f of n. Okay, what is this concept? C into g of n. See, this is the equation first. Okay, then see here, first part, f of n is less than equal to c into g of n. That is, from equation 1 we can write f of n is less than equal to omega, or instead of big OH of g of n. Are you getting? समजला हा पार्ट? हॅलो, हा पार्ट समजलाय का
Yes,
तुम्हाला? समजलाय ना? हॅलो,
yes, sir.
Yes, sir. Yes.
ओके. समजा in this equation, see left side, second equation which is written in red color, that is f of n. This equation, suppose I have written f of n is here, f of n, okay, which is greater than c into g of n. That is, from second equation we can write omega of g of n. That is, we can write omega of g of n is always less than f of n, is always less than big O of g of n. That is, big O denotes upper bound, omega denotes a lower bound, and this function lies between upper bound as well as in lower bound, and that's why this theta, instead of f of n we are writing here theta of g of n, theta of g of n. It here theta of g of n. So theta of g of n lies between lower bound as well as upper bound, and that's why it is also known as average bound. Are you getting? समजलंय?
Yes,
तुम्हाला
sir.
समजलंय? Okay, we'll take examples on this. Suppose f of n is given as f of n is equal to 2n plus 3. So we should have to find c1 into g of n and c2 into g of n by using this equation. So we'll take first upper bound, that is f of n. F of n is greater than f of n is less than equal to c2 into g of n, that is 2n plus 3 is less than equal to 5n, where c2 is any positive constant, n is greater than equal to 1. Satisfies this equation? Hello, are you getting? We are taken the half part of this formula. Hello, we have taken half part of this formula. Are you getting? तुम्हाला समजलं इथपर्यंत?
Yes, sir.
Okay.
Yes, sir.
Then we are taking next half part, that is C1. C1 into g of n is less than f of n. That is, we can write f of n is greater than equal to c1 into g of n. So f of n, that is 2n plus 3 is greater than equal to, suppose 2n is written, okay, same as it is, because here plus 3 is additional part. So we can combine these two equations. This is suppose equation 1, equation 2, then here 2n is less than equal to 2n plus 3 is less than equal to 5n. Here 2 is c1, 5 is c2, n is g of n, this part is f of n. Are you getting? मला समजलं इथपर्यंत? Suppose we want to draw a graph of this big theta or theta notation. First, see this example carefully, then we'll draw the graph. Okay. Don't leave the sessions in between. While when the session was started, at that time nearly about 103 students were present. Now only 91 students are present. Okay, I will take any time attendance. I will take attendance at any time. So don't leave the sessions in between. Okay, we are going to draw the graph of this theta notation. Okay. Suppose this is the function C1 into G of n. This is the function f of n. This is the C2 into G of n. Here C2 acts as upper bound. This is average. This is lower. And there is a point, only one point where three parts can satisfy, or three parts of this equation satisfies. That point is n0. Okay. Are you getting? हॅलो, समजलंय तुम्हाला?
Yes, sir.
Yes, sir.
Okay, then we are revising today's part. Which part we have studied? First, we have seen the big OH notation. Symbol is capital O. Okay. In this part, we have studied there are two types of functions, f of n and g of n. Okay. 1 minute. Okay, in big OH, there are two functions, f of n and g of n, and we are showing the relation between these two functions such that the f of n is equal to O, that is big OH, of g of n if there exists, if and only if there exist two constant. C is a positive constant and n0 is greater than equal to 1, and relation between these two terms can be expressed as f of n is always less than equal to C into g of n. Okay, for all values of n which are greater than equal to n0. And if we get a point where satisfies this equation, that point is known as average point or N0. From that N0 towards right side, it is uppermost or upper bound, and towards left side it is lower bound. We have seen in general equations, that is 1 is less than log n, is less than root n, less than n, is less than n log n, is less than n square, is less than n cube, is less than 2 raised to n, is less than n raised to n. Okay. So this general equation is applicable when n is large, that is greater than 10 or 11. This general equation is applicable for the large values. For small values, it is not possible. Okay, so big OH acts as upper bound. Then we have seen that big omega notation, that is symbol is like this. Okay, so same concept as in big OH, that is there are two types of functions, f of n and g of n, and the relation between these two functions, that is f of n is equal to omega of g of n if there exists c, if and only if there exists c is greater than 0 and n0 is always greater than equal to 1, and we can write this equation as f of n is always greater than equal to c into g of n. So this is the lower bound, omega also known as lower bound, and we have seen that the big theta symbol is theta, and these two functions f of n and g of n can be written like this: f of n is equal to theta of g of n, such that c1 into g of n is greater less than equal to f of n is less than equal to c2 into g of n. Here for right side it acts as upper bound, for left side it acts as lower bound, and this function lies between upper bound and lower bound. That's why this theta is also known as average bound. Okay, are you getting? समजलं इथपर्यंत?
Yes, sir.
Then one more question arises here: why these asymptotic notations are important? Why we are studying in this algorithm? What is the reason? This is the mathematical concept, but what is the reason why we are studying this concept in algorithm? So first reason is that they are give the characterization of the algorithm's efficiency in terms of space complexity and time complexity. And second reason, they allows the comparison of the performance of different algorithms. Suppose here a program to find greatest number among three numbers. Or greatest or largest number among three numbers. From three numbers A, B, C. I want to find which number is greater. Then how many ways can you write a C program? Hello. Okay, tell me which method you know. What is the first step? Suppose you have taken three integers A, B, C, you have entered the values printf, scanf, whatever you have written. Then we are going to write next statement. What will be the next statement? Okay, tell me. Suppose you have entered three numbers A, B, and C, and you want to find out the greatest or largest number from these three numbers. Then you have entered these three numbers. Then what is the next step? How can you identify which is the largest number from these three numbers? With if else, is it possible? Hello. Okay, with if else, tell me what will be the next step. Your return scanf statement, %d, 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 and A and B and C. Then what will be the next statement? Anyone? Hello, I am waiting response from your side. Okay. Nobody else? I will tell the procedure. Suppose I have written if A is greater than B. If A is greater than B, if this condition is true, then I will check A is greater than C. If this condition also true, then I will write printf A is greatest number. Suppose A is greater than B is true, but this condition becomes false, then I will go else part. Else, again I will check if B is greater than C. A is greater than B, then A is greater than C, then I will write printf A is greatest number. Suppose A is greater than B, this is a true, but A is greater than C, this becomes false. Then I will check B is greater than C, then here I will write printf B is greatest number. Suppose this condition becomes false, then else I will check okay. Then suppose this first condition becomes false, then I don't enter in this. I will check B is greater than C. No. Then I will check B is else. B is greater than A. If B is greater than A, then I will write here printf B else I will write printf C, whatever. Okay, this is one method. What is the another method? Second method is
By using
using,
logical and also we checks.
okay, that is if A is greater than B and A is greater than C, then and then A is greatest number. Or second condition, if B is greater than A and B is greater than C. Okay, this is the second method. What is the third method? First, we have used a if else ladder. Okay, second, we have used a if and logical operators. Third method, we are using only if statement. Suppose I have taken another variable m, and first I will give m is equal to a. Then I will check if m or b is greater than m. If this true, then m is equal to b. Then I will check again f. If c is greater than m, then print or m is equal to c, then print m. This is third method. Okay, what is fourth method? Without if else, can we write without if statement? Can you write a program? Or with if, but without logical operators, can we write? Yes, by using ternary operator. So for same program, there are different algorithms, different methods. Okay, so by using these asymptotic notations, we compare the performance of different algorithms, and these asymptotic notations are give the characterization of the algorithms in terms or algorithms efficiency in terms of space complexity and time complexity. Are you getting what is the asymptotic notation? Hello, asymptotic notation हा concept तुम्हाला समजलाय का?
Yes, sir.
Okay, we are stop here. Next part we'll see in next lecture.